Okay. Hello, everyone. We are the NLP Spy team, and today we'll be presenting on assisting patients of Alzheimer's and ADHD with an NLP-based spy device. My name is Shreya Udupa, and my teammates are Seth, Parth Sharma, and Seth San Miguel, and our principal investigator is Ms. Sahar Janikia. So before we talk about our project, I would like to give a brief abstract. Although NLP, or natural language processing, is used heavily in information and task management, we decided to combine its technical facets with those of neuro-linguistic programming, also known as NLP, the enhancement of physiological skills, and leverage our knowledge on the extraction of keywords to reconstruct shortened versions of conversations. So our vision of this project is to merge the gap between neuroscience and technology through creating and using a Raspberry Pi-based cognitive linguistic assistant device that records voice and sends shortened communication through email or a potential complementary mobile app. So this device would benefit those with speech or memory impediments, including neurodivergent students in the classroom and those struggling with mental health, autism, ADHD, and Alzheimer's.
Yeah, thanks, Shreya. So I guess I'll go over the introduction to this project and things you need to know before we dive into how we approach this challenge. So the purpose of our device, as Shreya mentioned, is to collect data to better understand how mental health patients can understand long, complex conversations. And some topics I'd like to address before we get into the weeds a little more is we'll discuss the research on cognitive impairments that our device can assist with. And this will be the neurological basis for our device. And I'll also go over Parth will go over the software integration, and I will go over how we approach this device using a Raspberry Pi. And some buzzwords you can be familiar with are text abstraction and named entity recognition. And all our code is written in Python, and some technologies we used can be seen below.
Great. Thank you, Nia. So before we head into the hardware and the software, let's go over the psychological basis and the applications. So when creating our code and our software, we have to keep these in mind in order to communicate effectively with mental health patients. So number one, it's a good idea to stray away from slang, unfamiliar words, complex vocabulary, nuance, bias, and sarcasm, as these aspects make it difficult for mental health patients to understand certain texts. Using specific keywords and repeating them shows that it creates an easy understanding with them, so they could catch on easily and understand from audibly hearing the same words. Another thing is to use clear, literal, and positive language, which is a form of communicating effectively, as well. Mental health patients would need to audibly hear you clearly and understand you in a literal sense. And then lastly, creating therapeutic communication by mentioning their passions, interests, and values is a key aspect in kind of gaining their attention, because they're listening for their passions and interests, which they can bond with and connect with.
Yeah. All right, here we go. Okay, so thanks, Seth, for that overview. I'd like to talk more about the hardware that we used in this project specifically. So we decided to go with the Raspberry Pi because of its open source nature and the fact that it would be very easy to reproduce our work because it's open sourced and anyone can access a Raspberry Pi. So we're not infringing on any copyrights or anything. So the way that we basically did this is we attached a microphone to the Raspberry Pi, and then we created a bash script to passively record data, and we sent this data to another computer, which would run a script in Python to process all the data in this recording with principles of NLP, and whatever was processed using NLP would then be sent back to the bash script and retrieve the final output, and then the process would repeat until it's terminated by the user.
Okay, thank you, Nia, for the explanation on the Raspberry Pi. So now I'll talk about what happens after we record our audio. So all of our code is written in Python. So after we've recorded this audio file, we convert it to wave, .wave, and then to a text format using Google Speech Recognition. So we go through some pre-processing, like removing stop words and unnecessary words from this text, and then we get into our our summarization. So first I'll talk about extraction-based summarization, which ranks remaining sentences on the relevance or the frequency, and it essentially outputs the highest ranked sentences that it finds that are the most important. So as you can see below, there is some code. Let's move on. Yeah. So now I'll talk about abstraction-based summarization, which is another form of summarization comparable to extraction-based summarization. So first, it's the same steps. The first few steps are similar. We use text preprocessing by removing stop words and word tagging. And then we're able to evaluate the TF-IDF value or the word frequency values. Then we calculate sentence scores based on this word frequency, and then create a sentence rank based on these scores. And using these sentence ranks, we're able to generate a summary using text generation. So as you can see below, there's some code there. Yeah. Okay, now I'd like to talk about extraction versus abstraction-based summarization. So after many tests using speeches from the past and the present, we found abstraction-based summarization works slightly better than extractive-based summarization. However, every situation is different. Like every case requires a different way of summarizing. So we still have to refine and further test these methods to figure out which is best for every scenario. And yeah.
Awesome. Thank you, Parth, for that. All right, so now we will go over our future works and our conclusion. So overall, we think that all our research this summer and previous research has successfully aided us in building this cognitive linguistic assistant device. And upon finalizing the design and the functionality of our device, we hope to test it, as well as possibly develop a mobile app that I was discussing earlier that would facilitate all these conversations. In addition, we're also writing and planning to publish a research paper detailing all our work soon. And so we would like to sincerely acknowledge our principal investigator, Ms. Sahar Janikia, for all the support and guidance that she's provided us throughout the duration of this project. We would also like to acknowledge the efforts of ASDRP for their support and various opportunities that they've brought forth to our team. And so here's some of the references that we used. And thank you so much for listening to our presentation.
Thank you, beautiful work, well done.
And we're open to any questions at this time if anyone has any.
Looks like nobody has any questions besides me. I was on that hardware part where you were talking about that you have the Raspberry Pi with the microphone, and then it will be sent to the other computer that had a bash script that will run a Python, right? But then why do you need to like go back at the start? Why would you need to make it run again?
So I actually, with the diagram, it seems like it seemed as though we were actually like kind of sending it back, but what was actually happening is the script was still running. I think the diagram kind of misconstrued. So the bash script is kind of constantly checking for new recordings, and then there's interval periods where it would then send information to the Python script to be processed. So it would keep running until
I see. Okay.